Welcome to another 88K model railroad video, and in this video we're going to look at the WIO board and the sensors. Now the sensors play a critical part in the full operations of the WIO board. So if the sensors don't work, you won't get any indications, and if there's no indications, then Rocrail will see or do or won't do anything. So in this video we're going to look at the sensor types, then the transistor and how it works, and then we're going to talk about why I chose the Darlington transistor array, and then we're going to look at everything on the bench itself. So we're going to see the live examples. So let's get started with that. Okay, so here we are at the bench, and now what you're looking at is a breadboard, and this is the device that I use to set up circuits, and actually to set up the demo board, the WIO demo board. I use this, and it becomes an intricate part if you're going to build circuits and whatnot, so you want to get one. Now, one of the things that I did, which is also key, is I set up this little array of LEDs. And that's the LEDs are basically what you see all over the place. I mean, everywhere, and it indicates that something electronic is working. So we use the LEDs to test out a lot of things. Now, let's start with a basic circuit. Now, some guys will find this boring, but I feel that it's important because then it covers, for people who may not be familiar with electronics and whatnot, or just starting out, that they're able to kind of learn and then build their knowledge base. So now here, we're going to make a basic circuit. And now here on the left-hand side, you see this is the power. I've got 5 volts coming into this rail, and then now this is where we distribute, or how we distribute the power. So you use what these are called jumpers. And now we're going to apply the 5 volts to this side of the LED. On the left side of the LED, it's called, in this particular case, it's called the anode, and the anode is a positive side. The cathode is the negative side. And now you make the connection from the positive to the negative. So we go from there here. This is the cathode side, and then now when we apply the ground, you see that the LED lights. So now we know that there's current flowing through by the LED. So this is kind of a manual type of scenario, but they use what they call a switch. So this is a tactile switch, and now it's more so of a controlled mechanism. And now we apply this ground here. So we can see that the circuit is configured, but we don't want the LED to come on until we want it to. And now when you press the button, it makes the connection and completes the circuit, and then you have the LED illuminates because of the current flow. So now this is the basics of the circuit. Now, a computer or any type of electronic device doesn't have a finger to press the button. So now we use what's called a transistor. So a transistor will do the same thing, but electrically. So here we have the cathode, which is the negative side. We connect it to, I should point this out. So on the transistor, you have 3 legs, and with the 3 legs, you have what's called the base, the collector, and the emitter. And the base is like the finger pushing, is this action. So when you apply current on the base, it's like doing that. So let's set up the circuit. Here's the collector. So from the cathode to the collector, and then from the emitter to ground. So now this circuit is similar to this when we had it wired and it's open. So now what I'm going to do is do the finger push, but we're going to do that electronically. So now here is the current that comes from, I'm pulling power, the voltage, and now this resistor is dropping the current way down low, because this similar to the LED cannot handle a lot of current. So now, and there's a calculation that you make that will cause this to what they call saturate. When the current saturates, then that's when the transistor will work or actuate. So now when you apply that, that right there is pushing the button, but now it's electronically. So now, let's say, for example, the pi pico is now going to put out the current that causes this transistor to flow and cause it to connect, and then cause the current to flow, which cuts on the LED. So now this is the basic electronics or portion of a switch. Now, if you look at this, this is where I made the transition from this transistor, single transistor, to this chip, which is called the Darlington transistor array. This has the 8 transistors inside the chip, and each one of them has a port, and adjacent port is the actual transistor that creates that connection. And now when you put this to ground, so you always need to provide a ground, and that's what the Raspberry Pi is looking for. So this would go to ground, and now I'll use this blue lead to replicate the GPIO pin here that goes to the transistor on this Darlington array. So now, typically what the Raspberry Pi Pico does is put 3 volts sitting here, and that 3 volts is looking for ground. And now if you take the voltage and then apply that voltage here, then it causes this to make that connection just like any of the other switches. And now you have each input for 8 inputs, and then now you can then support the 8 IOs on one side, and then the other 8 IOs on the other side of the Pi Pico. So now this is the basis of the circuit itself. So now let's look at the problem. So one of the viewers had a message, and he was saying that the Pi Pico and everything was set up fine, but he could not see any of the sensors being actuated. And part of that is because of the type of sensor that he has. And that's something that you have to watch out for. You've got to make sure that the sensors is going to do what we need, which is to apply the voltage. So I'm going to show you the first sensor that works correctly. And now that's this, this sensor, which is the photoresistor sensor. And now if you notice, it has the S lead, which is the signal lead, then the negative, and then in the center it has the power lead. So let's power this up. So now we're going to apply the voltage here to power up the sensor. And then we're going to give it a negative.